We can start. Okay.
Okay, so hello everybody. I'm Riccardo Soro, and I'm a DevOps consultant at Imola Informatica. And I've been working in IT for the last 8 years.
I'm Nicolas. I'm working as a platform engineer in Imola Informatica. We are specialized in banking enterprises. And this is our first KCD as a speaker. And to be honest, this is my first experience as a speaker. So every feedback is appreciated, and sorry for my exposure. I'm a bit anxiety. So, start. A long time ago, in a galaxy far, far away, we are starting to talk with Riccardo in a rare, relaxed moment between one war room and another. And we are talking about generative AI. And we start talking how to integrate generative AI in platform in a regulated context. For who don't know, the regulated software is a software that is subject to law, standard, or specific regulation. For example, finance, aerospace, automotive, medical, health, etc. So we are two guys passionate from automation and innovation, so the discussion is degenerated, but we don't want to tell a fairy tale or an unrealizable dream dropped from ivory tower, but we want to design a solution for the context where we're working, a solution affordable and realizable. To do that, we have considered all the environment we have around. So we have considered the cultural level of people that working in the bank. We have considered that technology that the bank have imposed in us. And we consider how resources we can use for that. Considering everything, we have defined a requirement list. For example, security. For a bank, we don't want to send our code or our data into a service that we don't have the governance on. We have considered the performance. Introducing generative AI don't be degraded the performance of CI/CD. We have to do a zero trust approach. Everything we generated by a generative AI is not so safe, so we have to check that it's something useful. And the object where we have to act on, and the amount of data we have to generate it, because if you generate 650 unit tests for an API, where the 95% of that don't compile, and propose that pull request a developer, the medium response of the developer is no. So we don't want to replace the developer or load them with more work. We want to be the help they would like to have. So we have defined the requirement list, and the list is performance, cost, security, quantity of generated data, and zero trust. Okay, it's not working. Okay, so if we think in an old-style DevOps process, introducing a new phase, a new step of generating AI is not optimal, because we introduce a delay in the build, in the delivery, in the deploy, and the only result we have is hundreds of gently call that say the pipeline is slow and they are in late because of us. So the first requirement is avoiding the degradation by introducing the generative AI. Well, what we have thinking? We have start thinking about a new modern approach like inner loop and outer loop, and adding a generative loop. A generative loop that gain the data and generate the data triggered after build, deploy, delivery, what you need, and propose a pull request for developer. But what we say before, we don't live in a world of infinite resources. We don't want increase the cost of infrastructure. We have to use just the resources the bank we have destinated. So we have thinking the first solution is to optimizing the running of the generative loop by running that out the business hour, for example, in the night or in the weekend. But above all, the other solution is to select the object where we want to operate. For example, if I have an application I with 95% of coverage, 10 code smell, and 1 low vulnerability, the second application, application B, with 80% of code coverage, many code smell, and 2 low vulnerability, and the application C with 60% of code coverage, 1,000 code smell, many bug, and many high vulnerability, there is no point in spending resources to increase the code coverage of the application A. I don't have any advantage to gain the code coverage from 95 to 96% in the application A, or from 80 to 82 in the application B. In the same way, I have no advantage in solve some code smell in the first 2 applications. Where I have a great advantage is targeting the application C and working only in the application C. So we don't overload the platform, but act only where is needed. It doesn't make sense to focus to have all the 100% at all, but it's important to first act in the worst application to increase the overall quality and security of the application pool. For example, in the bank, the platform manage about 80 projects and about 1,500 components. So if we have to operate in all the 1,005 components, the resource use and the time is very, 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 very high. So, but in what way?
So in previous slide, we talked about integration between generative AI and platform at an high level. So we talk about where, when, and what. And in this slide, we will see how we can, how tools can interact with each other and with the model. In our opinion, there is a trigger, a cron job that create a task, a job in a tool that can handle it. For example, Jenkins, Tecton, or whichever tool you use. This job need to retrieve information from a repository, for example, GitLab, information about the project that you want to analyze. After that, the job need to fetch metrics about that project, for example, from a Sonar Cube, metrics about quality and, for example, security, or also coverage. With them, so with project and metrics, the job can ask to the model to fix the code, and the model will answer with a new version of the code. This new version need to be tested by the job. So only if everything is okay for the job, so if the tests are okay, the job can push this new version to the repository. We talk about integration, but we didn't talk about models. So which one is the best for us? There are a lot of options in the market. The most famous are ChatGPT, Gemini, Claude. They are very famous and very good, but they are not self-hostable. And for us, it's a requirement because maybe you want to analyze a project that you didn't write. So maybe in that project, there are information that you don't want to share with someone else. So in our opinion, a self-hostable model is better. Self-hostable models means that you can take the model and put in your machine. So every information are keeping inside the net and aren't shared with someone else. Okay, so GPT, Gemini, Claude. There are some family of models that give you the model that you can host in your machine. There are Mistral, for example, Llama, and Databricks. And now that we identified our model, we need to configure it. We can do it with hyperparameters. Hyperparameters are a way that you can use to customize your model. There are some type of hyperparameters. The fourth one is prompt. Prompt is how you ask something to the model. In our case, it was easier because we asked the model to fix our portion of code. So we take the code and we put it in the prompt with the issue that we want to be fixed. And the response of the model include the new version of the code. On the right part of the slide, you can see that it's a paper written 1 year ago. And in this paper, you can see that sometimes for some model, there are some silly phrases that increase the performance of the model. So when you think about your prompt, you need to think that the prompt, there are not rules to create the perfect prompt. You need to try a lot of things, and sometimes some counterintuitive things can work well. And another thing to keep in mind is that usually prompt is the performance of a prompt depends on the model. So if you want to change your model, maybe you need to fix your prompt. Okay. Before we talk about other hyperparameters, maybe it's better to spend a few words about how generative AI works. If you ask something to a generative AI model, the answer will be created word by word, or in this context, they are called tokens. And the tokens to be put in that slot is chosen randomly from a set. In this set, there are the most probably token. With the probability of a token, the probability of a token is calculated by the model, and is for the model how correct is that word in that slot. And okay, now we can see the first hyperparameter. With the top k, we set the size of the set. So if we have, for example, the k value that is 3, the set of the token that the model can use is 3. On the other hand, if it is 5, the set is bigger. The next hyperparameter is top p. Top p works like top k, but works with probability and not with units. So, for example, if you look at the second example, you can see that with the p-value that is at 0.8, only the first token can be chosen because its probability is measured at 0.8. In the first example, the set is bigger because probability is 2. The last hyperparameter is temperature. Temperature is the most important because usually you want to keep, you want to fix the top k and top k and work with temperature. temperature is a multiplier that the model apply to the probability of each token. So if the temperature is below 1, the multiplier is major than 1. So the gap between the gap of the probability of each token increases. And if we, for example, take temperature to 0, we have that in theory the gap is infinite. So also the first token can be chosen by the model. And it means also that we have a deterministic model. And it's a good thing for us because we can test different prompts without the random part of the model. On the other hand, so if you have a positive temperature major than 1, we have that the gap decreases. And if you have an high temperature, the gap is very low. And so the model is more random.
Okay. As we see before, we have to limit the quantity of data generated. If you remember Bugs Bunny, less but better. So how reduce the data we have to generate? If we take our best application C, we don't need to solve all the code coverage, the vulnerability, the code smell, the bug, because we generated many data. So the solution we have to think is selecting the 2-3 things to operate. For example, the code coverage, we find the class with the last coverage, and just generated only the 3-4 tests to cover that classes. The vulnerability and the bug is the same. It not make sense to solve all the vulnerability, all the bug. For example, if I have 2 applications, one in the backend running isolated with an high vulnerability but a near zero exploitability, and the front-end application exposed online in the web with a low vulnerability but with a high level of exploitability, it's better choose to solve the vulnerabilities that make the big damage, so the low in the front-end application. But we have generated some code, but we have to verify that the test is useful and is functional before to propose to developer. So how we test the generated unit test? Well, the first step is that the project must compile, the test must pass, the coverage must increase, and the unit test must be of high quality. And how to test if the unit test is of high quality? From literature, we use the mutation test. The idea of the mutation test is if I have a quality unit test, if I change the code, the test must fail. So if I have an if statement, I generate a test for that if statement, run the test pass. If change the if statement, the test must fail. If the test don't fail, the test is not of high quality. It's similar in assert true equal true. The same thing we have to do with the solved issue. We have to validate that the issue that we have solved is of quality. So, like before, the project must compile, the test must pass and not have to reduce coverage or on other. And important, the generated code must solve the issue without introducing other bug or other issue. So the flowchart with we have synced for this validation is that the job start clone the project from Git, get the data from systems, generated the unit test, and start the first zero trust approach. We check if the code is formally corrected. We check if the project compiling. We check if the test is passed. We test if the tests are of high quality with the mutation test, and check if the coverage is increased. If it's okay, we propose the pull request to the developer. In the other case, we have to react the pull request. But what we say before, in a regulated context, we don't have the luxury to take the code generated by GenAI and take like this. We need a manually approved. We need that a developer or someone with competence that know the application, know the domain, know the all the environment, make the check at the pull request and accept that. It's all theory. It's all good, but we have tried to test something, or better, Riccardo test something with a small Java application. I've tested some of model proposed before, and we have evaluated by the dimension of the model, the computational cost of the model, the code coverage generated, and the issue resolved. And what we have seen, the main consideration, is that generating issue is more complex than providing test classes. The specialization is better than dimension. For example, Llama code that is not some great, but is specialized for generation code, get a better result each other. Another consideration is that some models don't require a GPU, like Mistral 7B. So you have a little dimension, a little cost, computational cost, but we have optimal result instead. What next? For us, this is only the starting point. What we have to do today is only a think. We have some goal, some wish, some dream. For example, we want to collaborate with open source projects. If some open source project want to collaborate, we are open to collaborate with us. We want to define the application prioritization and selection algorithm. And we want to define the selection and prioritization algorithm for the quality, vulnerability, and code coverage. And perhaps, if possible, targeting in the context. For example, if I work for a bank have the target of secure software. If I work for automotive or aerospace, I need a redundancy in driving system. If I work for medical, I need software quality and precision. The other thing we want to do, if we want to try other model with more contextual capacity, more than Llama code, we want to integrate with other tools because today in the bank with work, we only have SonarQube, dependency tracker, and Checkmarx 1. So there are many tools to explore. We want fine-tuning the model that we have tried, but the first important for me, it's based on one of the pillars of the platform engineering and innovation management, find pioneers, early adopter, to try to implement a solution that can run in a real world, in our real client. And last news of the last week, the University of Bologna have approved an internship for a student that is interested in generative AI and DevOps. So in a few days, starting the student to work with this topic. We are done. Thank you. Thank you very much.